Hi, I am Gnana Brintha, Assistant Professor of Electrical and Electronics Engineering from Emmanuel Arasar JJ College of Engineering. Today we will see the topic from the electrical vehicle architecture. First, history of electric vehicles. Early development in 1828 to 1835, early electronic motors were developed by inventors like Annius Jetlick, Thomas Davenport, and Robert Anderson. In 1880s to 90s, electric cars gained popularity in the US and Europe due to their quiet operation. Quiet means the vehicle works with little noise. In 1899, La James condemned the first vehicle to exceed above 100 kilometers was electric. Next, decline of electric vehicles. 1910 to 1930s, mass production of affordable gasoline cars made electric vehicles less competitive. Next, internal combustion engines. Improved road infrastructure, longer range and faster refueling further favorite the internal combustion engines vehicles. In 1930s, early electric vehicles nearly disappeared from the market. Next, rebirth and research era. In 1960s to 1990s, sparked renewed interest in alternative fuels. Companies like General Motors and Toyota started electric vehicle research. In 1996, General Motors introduced the electrical vehicle one of the first modern electric cars. Modern era. 2000s present. 2008, Tesla Roadster launched the first highway legal electric vehicle with over 200 miles range using lithium-ion batteries. Government incentives. Policies promoting zero-emission vehicles boosted electric vehicle development globally. In 2020s, major automakers like Tesla, Nissan, Hyundai, Tata, Mahindra, and BYD led the market. Battery cost reduction and charging infrastructure improvements accelerated adoption. Current and future trends. Battery technology. Shift from lead acid to lithium ion research and solid state batteries. Electrical vehicles types. 1. Battery electric vehicles or BEV, fully electric vehicles. Next, PHEV means plug-in hybrid electric vehicle, combines battery and fuel engines. Example, Toyota Prius PHEV. Next, HEV, hybrid electric vehicle, charges battery through engine and regenerative braking. Example, Honda Insight. Smart grid and V2G vehicle. V2G means vehicle to grid, integration with renewable energy and energy storage. Next, evolution of electric vehicle. First generation, second generation, third generation, fourth generation, fifth generation, and future of electric vehicles. First generation in 830s to 1800 1830s to 1850s, early concept of battery powered vehicle emerged. 1870s to 90s, early electric cars used non-rechargeable batteries. Features of first generation: limited range and speed, silent and clean compared to noisy and smoky gasoline engines. Notable models: second generation Ford Model T made gasoline cars affordable and widely available. Limitation of second generation electric vehicles: limited speed and range, lack of charging infrastructure. Third generation, oil crisis in 1970s and rising environmental concerns, focus on reducing emissions and dependency on fossil fuels. Limitation of third generation: short battery life, low driving range, high cost and low consumer interest. Next, fourth generation, 2000 to 2010s. Technological advances: lithium ion batteries replaced lead acid, improved battery management system. Next, fifth generation. The current trends into 2020s present widespread adoption of battery electric vehicles and plug-in hybrid electric vehicles. Shift toward autonomous, connected and shared mobility. Next, future of electric vehicles. Beyond 2030s, expected developments: longer range, above 1000 kilometers per charge. Next, wireless charging and solar electric vehicles. Next, global electrification of public transport. Types of electric vehicles. First, series hybrid vehicles. A series hybrid vehicle is a type of hybrid vehicle in which the internal combustion engine does not directly drive the wheel. Instead, the engine is connected to an electrical generator which produces electricity to power the electric motor or charge the battery. Working principles of series hybrid vehicle. The basic energy flow in a series hybrid vehicle is fuel, internal combustion engine, generator, power electronics. Next, electric motor to the wheels. The battery is also connected to the electrical system. Battery, power electronics and electric motors are connected series. When the vehicle is operating, the engine drives the generator to produce electrical energy. This electrical energy can either be supplied directly to the electric motor or stored in the battery. The electric motor then provides the mechanical power required to drive the wheels. Working principle: in a series to parallel hybrid low speed operation, the electric motor can drive the wheels using energy stored in the battery. The engine may remain switched off. In normal driving, the internal combustion engine can provide mechanical power directly to the wheels while also supplying power to the electrical system. High power operation: both the engine and electric motor provide power simultaneously to drive the wheels. Next, regenerative braking. During braking, the electric motor operates as a generator. The recovered electrical energy is stored in the battery. Battery charging: when necessary, the engine can drive the generator to produce electrical energy for charging the battery. Advantages: the engine does not need a direct mechanical connection to the wheels. The engine can operate near its most efficient operating point, provides smooth and quiet electric motor driven operation. Regenerative braking improves energy efficiency, suitable for applications with frequent stopping and starting. Disadvantages: required additional components such as generator and power electronics. Energy passes through several conversion stages causing losses. The system can be heavier and more expensive than a conventional powertrain. Applications of parallel hybrid electric vehicle. Series hybrid systems are commonly considered for city buses, delivery vehicles, locomotives, and other vehicles that operate with frequent acceleration and braking. Parallel hybrid vehicle. A parallel hybrid vehicle system is a type of hybrid vehicle in which both the internal combustion engine and the electric motor can provide mechanical power to drive the wheels. Unlike a series hybrid, the engine in a parallel hybrid has a direct mechanical connection to the drivetrain. Working principle: the basic power flow is fuel, internal combustion engine, transmission, next wheels, and battery, inverter, electric motor, transmission, two wheels. The engine and electric motor can operate independently or together depending on the driving condition and power requirements. During low speed operation, the vehicle may use the electric motor alone. During high power demand, such as acceleration or climbing, both the engine and motor can work together. During braking, the motor can act as a generator and recover energy through the regenerative braking. The main components are internal combustion engine, electric motor, battery pack, inverter, transmission, vehicle control unit, regenerative braking system. Operating modes. First, the electric mode. The electric motor drives the vehicle while the engine is switched off. Engine mode. The internal combustion engine provides most or all of the driving power. Combined mode. The engine and electric motor operate together to provide higher power. Regenerative braking. The electric motor works as a generator and charges the battery during braking. Charging mode. In some systems, the engine can provide power to charge the battery. Advantages. Advantages of the parallel hybrid system. Combines the benefits of series and parallel hybrid system. High fuel efficiency under different drive condition. Electric motor provides good low speed performance. Engine can operate near an efficient operating region, suitable for both city and highway driving. Disadvantages. More complicated control system, higher manufacturing cost, more components and greater system complexity. Power conversion through multiple paths can introduce energy losses. Requires sophisticated energy management strategies. Next type, series parallel configuration. Series parallel hybrid configuration. A series parallel configuration, also called a power split unit hybrid, combines the operating principles of both series hybrid and parallel hybrid vehicles. It allows the vehicle to be driven by the electric motor, the internal combustion engine, or both together depending on driving condition. Basic configuration. The typical energy flow is: first, fuel to the IC engine to power split device to wheels, or fuel to IC engine generator, battery or motor, 2 wheels. Next, battery, inverter, electric power, 2 wheels. The main components of series parallel hybrid system: internal combustion engine, electric motor, generator, battery pack, inverter or power converter, power split device, transmission, vehicle control unit, regenerative braking system. During braking or deceleration, the electric motor can operate as a generator. This process, called regenerative braking, converts some of the vehicle's kinetic energy into electrical energy and store it in the battery. The main components: internal combustion engine produce mechanical energy from fuel. Generator converts engine mechanical energy into electrical energy. Battery pack stores electrical energy. Power converter or inverter, it controls and converts electrical power. Electric motor converts electrical energy into mechanical energy. Vehicle control unit controls the operation of the engine, battery, generator and motor. Regenerative braking system recovers energy during braking. Advantages: higher efficiency compared with conventional vehicles. The engine and motor can share the driving load. Good acceleration performance. Regenerative braking reduces energy losses. Generally more efficient for a combination of city and highway driving. Can be smaller and simpler than some series hybrid arrangement. Disadvantage: mechanical connection between the engine and wheels makes the drivetrain more complex. Requires sophisticated control systems. Has more components than a conventional vehicle. Engine operation can still result in a fuel consumption and emissions. Packaging the engine, motor, battery and transmission can be challenging. Next, figure shows the simple block diagram of series parallel hybrid vehicle. First, fuel tank, next IC engine, power split device, mechanical power generator, battery, inverter, electric motor, wheels. First, the fuel stored in a fuel tank. Next, the IC engine system. Next, the power split unit device is used to split the power. Next, mechanical power generator. This generator gives energy to the battery and then given to the inverter to motor. Finally, the power goes to the wheels. This is all about the electric vehicle architectures, types. Thank you.